Hello everyone, so welcome to the lecture number 25, which is the last lecture of this chapter, that is chapter number 6, lines and angles. Okay, so in this lecture we will discuss about two remaining problems from the exercise 6.3. Okay, so let us start with the first question. So here is the first question. So it is a figure, and in this figure some data are given regarding this figure. Okay, so it is given that in this figure the side QR, since PQR is a triangle. Okay, so in this triangle, this side QR is produced to a point S. That means this side is being produced in this direction towards the right hand side up to S, like this. Suppose this is a triangle, okay, PQR, then this QR side is produced to the right hand side up to S. If the bisector of angle PQR, okay, and angle PRS meet each other at T. So it is given that there are two angle bisector. One for the PQR angle. Suppose you are considering this triangle, then this is the PQR angle, and which angle? PRS, this angle. Okay, it is given that the angle bisector of this angle, suppose this is the angle bisector, and the angle bisector of this angle, suppose this is the angle bisector, right? Now these two angle bisector meet each other at a point T. It is given in the question. Okay, so since it is the angle bisector, that means this angle is equal to this angle. So you can write this is equal to this, and this is the angle bisector of PRS, this angle. So you can write this angle is equal to this angle. This angle is equal to this angle. Okay. Now I think you will easily understand the data that is given in the question. Okay. Next, from this data, we have to prove that QTR is equal to half of QTR. You have to show that this angle is equal to half of QPR, this angle. It means you have to show, suppose this angle is 60 degree, then this angle is the half of this angle, that means this angle is 30 degree. Or if this angle is 100 degree, then you have to prove that this angle is 50 degree. Or if this angle is 70 degree, then you have to prove that this angle is 35 degree. So ultimately you have to prove that this angle is the half of this angle. Okay. Now let us prove it. Okay. So first of all, you can easily understand the data that is given in the question. It is given that PQR is a triangle. This side is produced to the point S. Now there are two angles, this angle and this angle. Now we find the angle bisector of this angle and angle bisector of this angle, right? Then these two angle bisector meet each other at a point T. Then we have to prove that this angle is the half of this angle. Okay, so let us prove. First, consider only the triangle PQR. For triangle PQR, right? For the triangle PQR, this is PQR, then this point is S. Now, this is an exterior angle, yes or no? Yes, this is an exterior angle. So, PRS is an exterior angle. Now, according to the theorem 6.8, we can write that the exterior angle is equal to sum of two interior opposite angles. Here, if it is the exterior angle, then this angle and this angle are known as interior opposite angles. So, PRS is equal to this angle RPQ plus this angle PQR. Understood? This is due to theorem 6.8. Okay. Now we can write this term first, RPQ. RPQ, or you can write QPR, no problem. Suppose I am writing QPR plus this angle is equal to this angle. Okay. So I am writing this term first, then this term, right? Next, here you find what is the value of QPR. QPR is equal to, whenever PQR move to the right hand side, then it will be subtracted. So it will be PRS angle minus PQR angle. Understood? So this is our equation number 1. Right? So we find QPR angle is equal to PRS angle minus PQR angle. Okay. Next, if we consider this as a triangle, this. Which triangle? Like this, and then this, and this. Okay. TQR. TQRS. Okay. So for triangle TQR, okay, for this triangle TQR, this is also an exterior angle. Okay, understood? So we can write that TRS, okay, is equal to sum of two interior opposite angles. If you consider this as an exterior angle, then these two are interior opposite angles. Similarly, if we consider this for the triangle TQR as an exterior angle, then this angle and this angle, that means this angle, are two interior opposite angle. That is why I am drawing this figure in another part. Okay. So TRS is equal to this angle means RTQ, or you can write QTR plus this angle RQT. Okay. Yes, RQT or TQR. Okay. Next, we can write this term first, QTR plus TQR is equal to TRS. Now find QTR is how much? Then this term will move to the right hand side. It will be TRS minus TQR. Simple. So from the two triangle PQR we find equation 1. For the second triangle QTR we find equation 2 from theorem 6.8. Understood? Next thing. Okay, so it is given that QT is the bisector or angle bisector of this angle. Which angle? This angle, QT. Okay, so QT is angle bisector of which angle? This angle, PQR. Understood? PQR. Okay, so this angle will be this angle. Yes or no? Yes. If it is 60 degrees, then this is 30, this is 30. If it is 80 degrees, then this is 40, this is 40. And this one is the half of the total angle. Yes or no? Suppose this is an angle, this is the angle bisector, right? Then this one is the half of the total angle. Similarly, this one is the half of the total angle, because an angle bisector divides an angle into two equal halves. So we can write that this part means which angle? TQR. TQR is equal to half of the total angle, half of PQR, right? So when this 2 moves to the left hand side, it will be multiplied. Since in the right hand side 2 is in the denominator, So when it moves to the left hand side, it will be multiplied with TQR. So 2 times of TQR is equal to PQR. Okay. Similarly, RT or TR is the angle bisector of this total angle PRS. Okay. So this angle is equal to this angle, and one angle, this part is the half of the total angle. Similarly, this part is the half of the total angle PRS, right? So we can write that RT is the angle bisector of PRS. So we can write this part TRS is equal to half of the total angle PRS. And similarly, when 2 moves to the left hand side, it will be 2 times of TRS is equal to PRS. Okay, you understood? Okay, next we have to prove this thing. So, as from the equation 1 we get, from equation 1 we get QPR. Understand it clearly? QPR is equal to PRS minus PQR. Okay, this is equation number 1. So here QPR is equal to, okay, PRS. PRS is how much? See, we find PRS is 2 times of TRS. Yes or no? Yes, we find it. Suppose it is equation 3 and it is equation 4. Right? So in equation 4 we find that PRS is equal to 2 times of TRS. So in this place we can write 2 times of TRS. Right? Minus PQR. See equation number 3. PQR is 2 times of TQR. So in this place we can substitute PQR is equal to 2 times of TQR. Okay, that is why we find these two equations in order to substitute in this place and in this place. Right? So we find QPR is equal to. Now we can take 2 as common from these two terms, so that it will be TRS minus TQR. Okay. So wherever these two moves to the left hand side, it will be divided, because in the right hand side it is in the numerator. So when it moves to the left hand side, it will be divided, or this 2 moves to the denominator. So half of QPR is equal to how much? TRS minus TQR. Okay. Next, half of QPR is equal. Now see the equation number 2. In equation 2 we find QTR is equal to TRS minus TQR. Here see, TRS minus TQR. TRS minus TQR. So TRS minus TQR is equal to QTR. You find it from equation 2. So in this place we can substitute QTR. You can write the reason here as we get it from equation 2. Okay, so in this place we substitute TRS minus TQR is equal to QTR, and this is our final result. Or you can write this term first. What we get? We get QTR is equal to, then this term half of QPR. QTR means QTR. This angle is half of QPR. QPR. This angle. Here we need to find it. QTR. Here also QTR is equal to half of QPR is equal to half of QPR. So we finally proved what is needed in the question. Okay, that this angle is half of this angle. Okay. So finally coming to the last question of this chapter, that is question number 6 from exercise 6.3. So in this question it is a figure, okay, and in this figure it is given that PQ, this PQ is parallel to ST, okay, it is given, and this angle is given. This angle is 90 degree, this angle is 65 degree, this angle is 28 degree, and you have to find the value of two unknown variables x and y. Okay, so these are the data that has been given. These two lines are parallel and these three angles are given. Okay, so let us find the unknown variables. So solution. First, consider the triangle SQR. Which triangle? This triangle. Understand it clearly. SQR triangle. Then for this triangle, this is the exterior angle. Forget about this thing. Only consider this triangle. So this is the exterior angle. Now we know the exterior angle is equal to sum of two interior opposite angles. So this angle and this angle. Suppose this angle is Z. We suppose it. Then this exterior angle is equal to this angle plus this angle. Okay. So you can write 65 degree is equal to this angle plus this angle. Suppose we take it as Z. It is due to theorem 6.8. So Z is equal to 65 degree minus 28 degree, that is 37 degree. So we find the value of this angle is 35 degree, right? But our target is to find x and y. Okay, so since it is given that since PQ is parallel to ST, okay, so PQ is parallel to ST, like this. PQ is parallel to ST, and QS is a transversal line. QS. Only consider QS. Forget about other two lines. QS is a transversal line and PQS are two parallel lines. Then this angle is given 35 degree. Then we know that this angle is equal to this angle, and this angle is given HX. So if these two lines are parallel and this is the transversal line, then this angle is equal to this angle. Why? Because they are alternate interior angles. Okay, so we can write that this angle is equal to this angle. Why? Because they are alternate interior. So we find the value of first unknown variable x. Okay, now we will find another variable y. How? By considering PSQ as a triangle. Okay, so if we consider PSQ as a triangle, then we know the sum of three angles of a triangle is 180 degree according to the theorem number 6.7. So this angle plus this angle plus this angle is equal to 180 degree. So y is equal to 180 degree minus 125 degree, and y is equal to 55 degree. Okay. So finally we reach at the two unknown variables value, that is x is equal to 35 and y is equal to 50.